Let's take a look at linear inequalities and absolute value inequalities. First, let's review our set builder, interval, and graphs of the different forms. We have our first one, which is x is less than 1, and then our set builder is easy. Our set builder, you put curly brackets around it, you put an x, you put a vertical bar, and then whatever you came up with over there. Now how you read that is this is a set of all x values. That vertical bar is such that x is less than 1. Now for our interval notation, x is less than 1, which means it's going to negative infinity. And negative infinity is a very small number you never reach because you can keep subtracting 1. And then 1 goes here, and its x is less than, so I'll put parentheses, so parentheses means it doesn't include it. And then our graph, we have 1, and then parentheses on it, and then we're shading to the left, going to negative infinity. We have x is less than or equal to 2. Now I'm putting numbers here just so we can see it instead of putting like a's and b's, but you can have any number there. And again, this will be easy for set builder. It'll be a set of all x values such that x is less than or equal to 2. Now it's going to negative infinity again. And I put a 2, and since it's less than or equal to, then we put a bracket. Now bracket on 2 there, then bracket on 2 here, and again it's being shaded to negative infinity. Now we have x is greater than 5, for example. This is our set builder. And then have parentheses on the 5, and it's going to positive infinity. And again, parentheses on a 5, and it's shaded to positive infinity. And then we have x is greater than or equal to, 10. You can have any number there. Greater than or equal to. Bracket on 10 because it's a greater than or equal to, and it's going to positive infinity again. Like that. Now, if it's between two values, like x is between 1 and 2, again, set builder is very easy. Put x with a vertical bar, and then 1 less than x less than 2. Now, it'll be parentheses 1 comma 2 parentheses. Parentheses because these are both less thans. Less thans means it doesn't include a number, which is parentheses. And then I have parentheses on 1, parentheses on 2, and shade in between them. Now, if you have set builder, the graph is very easy. You know, parentheses on the 1, parentheses on the 1, parentheses on 2, parentheses on 2. And then you shade them. Let's see. 3 is less than x is less than or equal to 4. Again, set builder is very simple. Interval is a little harder, but less than on the 3 means parentheses. Less than or equal to on the 4 means brackets. Then our graph, parentheses on the 3, brackets on the 4, and shade in between. And less than or equal to there, and then less than here. Set builder would look like this. Bracket on the 7, parentheses on 10. There we go. And one last one. Less than or equal to is on both of them. So we got x such that this is true. And then bracket on both of them. And on a graph, bracket on both of them. And that'd be your answer. Or an answer. That would be our form. Now let's look at our first problem. Excuse me. I knew it was coming. I just kept waiting. Okay, express each interval in set builder and graph. Well, here we have two numbers. Then we have bracket and parentheses. So I come up here. The ones that are two numbers are these bottom four, and I'm looking for a bracket parentheses, which would be the 7 and 10 form. So it's going to look like that. It wants set builder, so I come over here. This is what my set builder is going to look like, but instead of 7 and 10, I'm going to have negative 2 and 5. So this would be x such that negative 2 less than or equal to x less than 5, like that. Now in terms of our graph, if we come over here, it'll look like this graph over here, but instead of 7 and 10, we're going to have negative 2 and 5. Now until you get comfortable with interval notation and all those, I would use that table. You should eventually get to the point where you won't need to look at that table. You recognize that a bracket is the same as a less than or equal to. A parentheses is the same as a less than. And it's very easy if you have interval notation. See a bracket on negative 2, bracket on negative 2. Parentheses on the 5, parentheses on the 5. But those would be your answers for the first example. Okay, our second one. Got negative infinity and then 4. Okay, so we got negative infinity on the left side. We got parentheses around both of them. So we come up here. Negative infinity on the left side, parentheses around both of them, matches this first form. Set builder would look like this. And instead of a 1, we're going to have a 4. So this would be x such that x is less than 4. And if I looked at my graph up there, I'd have parentheses on a 4, parentheses on a 4. It's shaded to negative infinity because it's going to negative infinity, like that. And those would be our answers. Now the next two kind of go together. So let me put it. We got negative 5, 2, intersection, negative 3, 4. And our next one is negative 5, 2, union, negative 3, 4. Now this symbol right here is intersection. Not that I can spell. Well, that's bad. Let's try it again. Intersection. Now, graph-wise, intersection is the AND statement. Or math-wise, it's the AND. Now, graph-wise, this is where they are both shaded. So where they are both shaded. Over here, this symbol here is our union symbol. And this is the OR in math. Now, graph-wise, this is where anything is shaded. So that's where anything is shaded. Well, let's first draw the big graph, and then we'll write the answers down of each individual one of these. Smallest number is negative 5, and negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. Okay. So I got negative 5 to 2. So parentheses on negative 5, parentheses on 2, and I'm shading in between them like this. The other one is negative 3 to 4. So I'll do bracket negative 3 to 4 like that, and then I'll shade in between them. There we go. Okay, now let's write our answers down. Our first one here, the intersection of these. Graph-wise, there's where they are both shaded. Well, these are both shaded from negative 3 to 2. And bracket on negative 3, bracket on negative 3. Parentheses on 2, parentheses on 2. So whatever symbol's there, you just carry down. Now this one is where anything is shaded, the union. So where anything is shaded is from negative 5 to 4. Parentheses on negative 5, bracket on the 4. And those would be our answers for those two. Now see, it says use graphs to find each set. Again, it's best to visually look at this. What they're getting ready to point out to you is that later on when we're dealing with absolute value inequalities, sometimes it's hard to understand how they get their answer unless you look at the graph. And then if you look at the graph, it makes perfect sense why it comes up with what they do. So let me save this page. Take a drink also. So CA linear and absolute value inequalities. Page 01. Next ones are linear inequalities. The next 1, 2, 3, 4, I guess. Yeah, next 4 of them. So let's take a look at how to solve a linear inequality. We have our note up at the top. It says at any step, combine like terms and combine numbers. Step 1, get rid of parentheses. And remember, we do this via the distributive property. Step 2, get rid of fractions. And we'll do this by multiply everything by the LCM of all the denominators. Step 3, get everything with an X on the left side, numbers on the right side. Now the reason why I say left side and right side on that is then it'll match our forms exactly on that table I first put up. So until you get comfortable with it, I would stick with that. And then the fourth step, divide both sides by the number in front of the X. We have a note that goes along with this that says if you multiply or divide both sides by a negative number, flip the inequality symbol. So flip the inequality symbol. Now let's take a look at some problems. We got 3x minus 2 is less than 13. Okay, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x on the left side, numbers on the right. So I'll take negative 2 over to the right side. Now, just like when we're dealing with the equals, when you take anything across your inequality symbol, the sign changes. The negative 2 becomes a positive 2. Our note up at top, in any step, combine together like terms. 13 plus 2 is 15. And last step, divide both sides by a number in front of your x. So we're going to divide both sides by 3. So these cancel. And we got x is less than 5. Now, it says, other than use interval notation, express solution set, graph it. For interval, it's x is less than negative 5, so it's going negative infinity. And it's less than 5, doesn't include 5, so put parentheses on it. And parentheses on the 5, parentheses on the 5, and shading to negative infinity. Let's take a look at this one. We got 10x plus 35. It's less than or equal to 4x minus 11. Well, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x on the left side and numbers on the right side. So I'll take 4x over the left side and 35 over to the right side. Anytime you take anything across your inequality symbol, the sign changes. So 4x becomes a negative 4x. The 35 becomes a negative 35. Combine together like terms at any step. 10x minus 4x gives us 6x. It's less than or equal to negative 11, negative 35 is negative 46. Last step, divide both sides by a number in front of your x. So we're going to divide both sides by 6. Those 6's cancel. Now notice I didn't flip my inequality symbol, did I? I'll talk more about that here in a second. 46 and 6 are both divisible by 2 at least. That's negative 23 over 3. And that looks like our answer. Interval notation, it's going to negative infinity. Less than or equal to, so it includes the negative 23 over 3. So I'll put a bracket on it. Graph-wise, bracket on negative 23 over 3. Down here, bracket on negative 23 over 3. And I'm shading it to negative infinity. Okay, now I said that when I divided by 6, I didn't flip the inequality symbol. But that's a negative 46. But look what this says. If you multiply or divide both sides by a negative number, so we're talking about the number down in the denominator, the 6. Now we're dividing by a positive 6, so that's why we don't flip the inequality symbol. A lot of people see negatives, and anytime they see it, they start flipping the inequality. Let's take a look at the next example. So we got negative 8 times x plus 3 is greater than 3x plus 20. Okay, first step, get rid of parentheses. Well, I'm going to take this negative 8 and multiply it times the x and times the 3. Negative 8 times x is negative 8x. Negative 8 times 3 is negative 24. Now, we didn't flip our inequality symbol. I think that's a 20. Let me look. Yeah. We didn't flip our inequality symbol. That's where you go and multiply both sides by a negative number. Well, this negative 8 was already in our problem, and besides that, it's only multiplied by a little piece. Okay, third step. Get everything with an x on one side and numbers on the other. So I'll take 3x over the left side, negative 24 over here. I think I said that wrong. But get everything with an x on the left side, numbers on the right. So I got negative 8x minus 3x is greater than 20 plus 24. Anytime you take anything across your equals, sign changes, or across your inequality. Negative 8x and negative 3x gives us negative 11x. 20 plus 24 gives us 44. Last step, divide both sides by a number in front of your x. So we're going to divide both sides by negative 11. Now we're dividing both sides by a negative number, so our greater than becomes a less than. We flip our inequality symbol. And we got x is less than negative 4. That's going to negative infinity. Less than negative 4 means it doesn't include negative 4, so I put parentheses on it. And parentheses on negative 4 down here, shaded to negative infinity. Let me get a drink and then save this one. And let's look at this one. We got 3x plus 2 over 3x minus 2. So 3x minus 2 over 5 plus 2 is greater than or equal to 4x minus 1 over 15. Now our first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all our denominators. Now we got 5 and 15, so our LCM is 15. So multiply everything by 15. So multiply the first fraction by 15, multiply the 2 by 15, and then the fraction on the right side by 15. Now 5 and 15 both divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. 15 and 15 both divisible by 15. 15 divided by 15 is 1. 15 divided by 15 is 1. If you end up with all 1s in your denominator, you pick the right LCM. Well, I got 3 times 3x gives us 9x. 3 times negative 2 is negative 6. 15 times 2 is 30. And 1 times anything doesn't change it, so that stays as 4x minus 1. At any step, combine together numbers. On the left side, negative 6 plus 30 gives us 24. Now, third step says get everything with an x on the left side, numbers on the right. So I take the 4x to the left and 24 to the right. So we get 9x minus 4x is greater than or equal to negative 1 minus 24. Combine together like terms at any step. 9x minus 4x is 5x. Combine together numbers. Negative 1, negative 24 is negative 25. Last step, divide both sides by a number in front of your x, which is a 5. Those 5's cancel. And we got x is greater than or equal to negative 5. Now it's going to positive infinity, and it's greater than or equal to, so it includes negative 5, so let's bracket, like that. And then bracket on negative 5, and shaded to positive infinity, which is to the right. Get a drink here. Okay, let's look at a linear inequality with 3 sides. So solving a linear inequality with 3 sides. Those are referred to as compound inequalities, but there's 2 different types of compound inequalities, so I wanted to put that in this manner. Okay, now at any step, combine together like terms, combine together numbers. I want to write that down. First step, get rid of parentheses. Second step, get rid of fractions. Third step, get everything with an x in the middle. numbers on the other two sides. And step 4, divide all three sides by the number in front of the x. Now we still have our note here. Says if you multiply or divide all three sides by a negative number, flip the inequality symbols. Let's take a look at a problem dealing with these steps. Okay, so we got 8 is less than or equal to 2x minus 4 is less than 23. Okay, it's a linear. We got x to the first power, and we got three sides. Again, this is called a compound inequality. Now, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x in the middle, numbers on the other two sides. So I'm going to take the negative 4 over to both the other sides. So this can become 8 plus 4 is less than or equal to 2x is less than 23 plus 4. Now at any step combine together numbers, 8 plus 4 is 12. And 23 plus 4 is 27. Last step, divide all three sides by the number in front of your x, which is 2. So I divide that by 2, and this by 2, and then the 27 by 2. Well, 12 divided by 2 is 6. Those 2's cancel, leave me x, and then 27 over 2 there. Now they don't say how to write their answer, so I'm just going to leave it that way. But it could be interval, set builder, graph. It's hard to say. I always hate when they're not very clear on how they want the answer. Let me save that. And then we'll look at absolute value inequalities. So let's see, absolute value inequalities. We have two cases of that. Our first case is where we have the absolute value of something is less than something else. If you have it in that form, then you can rewrite it as negative q is less than p is less than positive q. Now our second case is where you have the absolute value of something is greater than something else. Well then, you can rewrite it as p is less than negative q, or p is greater than positive q. Now this does not mean you can choose one or the other. If it's case 2, you have to plug it into both of these pieces. Now the absolute value has to be by itself for you to use this formula. So let's take a look at a problem. So we got the absolute value of 6x minus 1 is less than 13. Okay. The absolute value is by itself, so that fits. And specifically, its absolute value is less than. Well, if I come here, this is case 1. Absolute value is less than. So what's inside the absolute values are p. The other side is our q. So from our formula, we got negative q is less than p is less than q. So everywhere I have a p, I'll plug in 6x minus 1, and everywhere I have a q, I'll plug in 13. So I got negative 13 is less than 6x minus 1 is less than positive 13. Now we want to solve for x, so we want to get x by itself in the middle. So we go through our steps. First step, get rid of parentheses, don't have any. Second step, get rid of fractions, don't have any. Third step, get everything with an x in the middle, numbers on the other two sides. So take -1 to the right side and to the left side. So I got -13 plus 1 is less than 6x is less than 13 plus 1. Combine together the numbers at any step. -13 plus 1 is -12. And 13 plus 1 is 14. Now divide all three sides by a number in front of your x. So we'll divide all three sides by 6. And that gives us -2. Those 6's are gone. We got x. And 14 divided by 6. The top and bottom both divisible by 2. So that gives us 7/3. Doesn't say how to write the answer, so I'm just going to leave it that way. I'm sure they put an interval or set builder or something like that. Okay, let's look at our next one. The absolute value of 7x plus 2 is greater than 19. Okay, the absolute value is by itself on the left side, which is what we need, and its absolute value is greater than. So that's case 2. Well, again, what's inside the absolute value is our p. The other side is our q. So we'll plug them into our formula. It says we got p is less than -q, or p is greater than q. So I have 7x plus 2 is less than -19, or 7x plus 2 is greater than a positive 19. Now this is a compound inequality, but we're going to solve each one of these separately. So I'll take 2 over the right side here. We got 7x is less than -19 minus 2. Now I'm going to go ahead and finish this one. -19, -2 is -21. Divide both sides by 7. And we get x is less than -3. Now over in this one, we'll take 2 to the right side. So we got 7x is greater than 19 minus 2. 7x is greater than 17. Divide both sides by 7. And we got x is greater than 17/7. Now there's an or between them. Now I'm happy with that answer right there. If you're curious what interval notation looks like, well, x is less than -3, that's going to negative infinity. That's -3. Less than -3, so it doesn't include -3, so parentheses there. Over here, x is greater than, so it doesn't include it. So we've got parentheses, 17/7, and it's going to positive infinity. And we put a union symbol in between them. Remember, union in mathematics corresponds to your or. And let's take a look at this one. X plus 2 is greater than or equal to -24. Now at first glance here, this looks like the greater than formula. Looks like it would be case 2. Now I know it's a greater than or equal to, but you just put a line underneath these to change them to the equal to part. Let me shift my seating here. Sometimes I sit too long and I need to move around. There it goes. But if I come down here, I notice that the absolute value is not by itself. So first thing I'm going to do is get it by itself. So I'm going to divide both sides by -4. Now remember, when we divide both sides by a negative number, we flip our inequality symbol. So this greater than or equal to becomes a less than or equal to. Well, -4's gone. And we got the absolute value of x plus 2 is less than or equal to +6. Well, now it's switched. It's no longer case 2, it's case 1, because it's a less than type problem. Now again, if it's a less than or equal to, I just put a line underneath here, line underneath here, line underneath here. Books never give you both formulas because it's implied that those are interchangeable. Okay, so what's inside of our absolute value is our p. and our other side is our q. And our formula is we got negative q is less than or equal to p is less than or equal to positive q. So I got negative 6 is less than or equal to x plus 2 is less than or equal to a positive 6. Trying to solve for x, so I'm going to take the 2 over to the other two sides. And then we get negative 6 minus 2 is less than or equal to x is less than or equal to 6 minus 2. Which gives us negative 8. 6 minus 2 gives us 4. And that's our answer. Let's take a look at this one. Got 3 is less than absolute value of 5 minus x. Now there's a problem with this. If I go up and compare it against my formulas always have the absolute value on the left side. That's where we need it. Excuse me. So if I come down here, put the absolute value on the left side, now I can switch them around, put the 3 over there. Now here the small end of the inequality opens up toward the 3, so when I switch it around, the small end has to open up toward 3. So you can't lose that relationship. And now this is the greater than formula. Absolute value is greater than. So this is going to be our p, and this will be our q. So we got p is less than negative q, or p is greater than q. Well, we'll plug in the 5 minus x for the p. It's less than negative q, so negative 3. Or 5 minus x is greater than a positive 3. Okay, so now we're wanting to solve for x. I'm going to take this, I'll do this one on left here first. Take 5 over to the right side. So we got negative x is less than negative 3 minus 5. Which is negative 8 is less than negative x is less than negative 8. I better go to bed. Now last step, divide both sides by number in front of your x. So we'll divide both sides by negative 1. And since we're dividing both sides by a negative number, we're going to flip our inequality symbol. So this becomes x is greater than positive 8. Now let's solve this one. Take 5 over. So we got negative x is greater than 3 minus 5. Negative x is greater than negative 2. Divide both sides by negative 1. Flip our inequality symbol. And we got x is less than 2. Now usually you put the smaller part of your answer on the left side. So it would be x is less than 2. And over here it would be x is greater than 8. And there's an or between them. And again, if you were to write an interval notation, this would be from negative infinity to 2. Parentheses on both of them. This would be from 8 to positive infinity, parentheses on both of them, and then a union symbol in between them. Let me save this. And let's look at the next problem. Okay, so we got 1 is less than absolute value of x minus 2/3, and then plus 8/3. Well, right away, I see I have the absolute value on the wrong side, so I can flip them completely. Put the x minus 2/3 absolute value of it on this side with the plus 8/3, and put the 1 over here. Small end of the inequality opens up toward the 1, so when I flip it around, the small end has to open up toward the 1. Okay. Now I have to have the absolute value by itself. So I'm going to take the 8/3, move it to the right side. And when I do that, it gives us a negative 8/3. Now if I were to put this in my calculator, what I'm going to get is a negative number. Now this is a mixed number. And with a mixed number format, you can do it in this manner. You take the number out in front times the number down below. If there's a negative, that negative has to go up on top. So we take 1 times 3 gives us 3, and then we add the negative 8. 3 and negative 8 gives us negative 5, and then the denominator stays the same. This is one of our oddball cases. Think what an absolute value does. Absolute value makes whatever's inside positive, or it can equal to 0. So when we're asking when is an absolute value greater than a negative number, it always is, no matter what you put in. So our answer would be negative infinity to positive infinity. We're going to talk a lot more about the oddball cases here in a minute. This is showing some of them actually in the problems. Let's see, 5 minus x over 2 minus 3 is less than or equal to 3. Now the absolute value is not by itself, so that's our first thing. We're going to take this negative 3 and move it to the right side. Okay, so we got 5 minus x over 2. Take it over there, it becomes a positive 3, which then would be less than or equal to 6. Okay. Now we got the absolute value by itself. This is a less than formula. What's inside the parentheses? What's inside the absolute value would be our p, and the other side would be our q. And our formula is we got negative q is less than or equal to p is less than or equal to positive q. So I got negative 6 is less than or equal to 5 minus x over 2 is less than or equal to positive 6. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, the 2, so we'll multiply everything by 2. So 2 times negative 6, 2 times 5, 2 times negative x over 2, and 2 times 6. And that gives us negative 12. 2 times 5 is 10. Those 2's cancel. We got minus x. It's less than or equal to 12. Third step, get everything with an x in the middle, numbers on the other two sides. So I'll take the 10, move it over to the other two sides. So we got negative 12 minus 10. It's less than or equal to negative x. It's less than or equal to 12 minus 10. That gives us negative 22. This gives us 2. Last step, divide everything by the number in front of your x, which is a negative. So divide that by a negative number, this by negative 1, and this by negative. And I flip my inequality symbols, so it becomes greater than or equal to. And we got 22 here, x, and negative 2. Now our form, though, requires us to have a smaller number over here. So I want negative 2 there, and 22 here. So I'll flip them around. Small end opens up toward negative 2, so small end opens up toward negative 2. Large end opens up toward 22, so large end opens up toward the positive 22. And that'd be my answer. Let me get a drink. I think that's the last problem, yeah. So let's talk about shortcuts, the oddball cases. Okay. Problems aren't too bad by themselves, but then you run across oddball cases, and those ones drive you nuts. Okay, so I'm working along, happy as can be, and I got the absolute value of something is less than a negative number. Well, remember, absolute value gives you a positive number or gives you 0. So when you ask yourselves when is it less than a negative 3, it's never less than a negative 3. So it would be a no solution or empty set. Now we looked at this one. You're working along, and all of a sudden you got the absolute value of something is greater than a negative number. Well, remember, absolute value gives you a positive number or 0. So when you ask when is it greater than negative 5, always is. So our answers would be negative infinity to positive infinity. All real numbers. You're working along. You get down to this point. and we got less than a negative number. Well, his first one we said was a no solution. And you might be tempted on this, but notice the absolute value is not by itself. If we divide both sides by negative 3, then we get the absolute value of x minus 7 is greater than positive 2. And it's no longer an oddball case. No, we don't have it less than a negative number. And even it changes. It was a less than formula, now it's a greater than. And then we can work it from there. That one just looks like an oddball case. You're working along happy as can be. And you have this right here. Come up with an absolute value is less than or equal to 0. Well, absolute value cannot be less than 0. That would imply it's negative. But it can be equal to 0. So this problem here, you drop the absolute value and just set it equal to 0. And we get negative 5 as our answer. Now you're working along, and you got x is, let me see, less than 5, or x is greater than 2. You look in the back of the book, and that's not what they have. They have a completely different answer, and you're sitting there, what? Well, if you look at the graph, here's 2. X is greater than 2 would be parentheses, and I'm shading to the right. Now this one is x is less than 5. Here's 5, and I'm shading to the left, less than. Now remember what or means. Or is where anything is shaded. Well, this is shaded everywhere, isn't it? So this would be negative infinity to positive infinity would be our answer. Here's another one very similar to that. Going along, you come up with this answer. X is greater than 2 or x is greater than 7. You look in the back of the book. All they have is x is greater than 2. And you're sitting there, why did they drop one of them? If I graph it, x is greater than 2. It'll be this right here. X is greater than 7 would be this right here. X is greater than 7 is included into this, so you don't need to write it down. The x is greater than 2 covers all that. So when we got a compound inequality with 3 sides, a linear inequality with 3 sides, the format we wanted in is this right here. We want a smaller number over here. We want our larger number over here. Of course, we want x in the middle, but then these symbols, we either want them to be less than or less than or equal to. Has to be in that form. We saw one of these already. You're working problem down, and you have this right here. It's not in the right form. But we can flip it around. We can put the 2 over here, 5 over here, x in the middle. Small end opens up toward 2. Small end opens up toward 2. Large end opens up toward 5. Large end opens up toward 5. And now it is in the right form. Going along, happy as can be, and we come up with this right here. Well, it's not in the right form. The smaller numbers here and larger numbers here, but these should be either less than or less than or equal to, not greater than. But if I flip it around, put the 7 here, put the 3 here, and x, so that the symbols are correct. Well, here large end opens up toward 3, large end opens up toward 3. Small end opens up toward 7, small end opens up toward 7. They would both be less than, but now my smaller number's not on the left side. This would be a no solution or empty set. If you cannot get it in that form, then it's equal to that. Now that pretty well, there's probably some other oddball cases, but that covers the big ones you'll run across. So let me save that.